Hello everyone, today we are going to talk about Cartesian coordinates. Cartesian coordinates, we have already studied that there are three coordinate axes. There are three coordinate axes in the geometry to represent a point. One is x-axis, another is y-axis, and third one, which represent height of any point in the 3D, will be z-axis. Let there is a point. If we want to give the position of this particular point with the help of these coordinate axes, then we will require three coordinates, which are x, y, and z coordinates. As these coordinates are represented by these coordinate axes, which are x, y, and z, this coordinate system is known as Cartesian coordinates. Here x represent length along x-axis, along x-axis means how much length this point has been covered along the x-axis. The y here represent the length along y-axis, and z here represent the length along z-axis. Okay, fine. X is the length along x-axis, this one. Y is the length along y-axis, this one, and z is the length along this axis. And these coordinates x, y, and z give a particular position of this point, and these are represented in the Cartesian plane, and hence these are known as Cartesian coordinates. This is a Cartesian coordinates of this particular point. Okay. Now we will talk about unit vectors in the Cartesian coordinates. Unit vector is a kind of vector which have a length of unity and give a direction, only direction. There are three unit vector in the Cartesian coordinates. One is I cap, which is a unit vector along x-axis. X-axis. Another one is j cap. It is a unit vector along y-axis. Third one is k cap, which is unit vector along z-axis. Cap is the sign which signifies here that the vector here is actually a unit vector. Okay. Now let's talk about the position vector of this point. In the Cartesian coordinates, position vector is a kind of vector which will join this point along with the origin, and this is a vector quantity. Let's denote it with the help of r vector, as r vector is joining this point from origin and its direction is along this point. R vector is here a position vector of this point. Let's write an expression for r vector. As you can see that I cap here is a unit vector along x-axis, therefore the length along x-axis, this one, can be represented by a vector which is x I cap. X is here denoting the magnitude of this line, and I cap is actually denoting the direction which is along the positive x-axis. As we have multiplied magnitude with some direction, this one complete quantity is now a vector quantity along x-axis. If we want to write this vector quantity along y-axis also, then we will simply write it as y j cap. X magnitude multiplied by some direction is now a vector quantity. Along z axis it is z k cap. Hence this unit vector r vector can be written as its length along this one is x, is along y is y, along z is z. Hence r vector can be written as a sum of these three vectors. It is in 3D. I cannot represent this vector in 3D because it is a 2D copy. You can imagine that it is in 3D. It is not in the YZ plane, it is in 3D. R vector can be written as xi cap plus yj cap and zk cap plus zk cap. This is the expression for a position vector in the Cartesian coordinate. It is a position vector of any point having a coordinates of x, y and z. Let's take an example. Let there is a point whose coordinates are 2, 3, 5, and if you want to write the position vector of this point, this one vector, this one r vector, then r vector will be written as 2i cap plus 3j cap plus 5k cap. It is a position vector. It has some direction also and have some magnitude also. Its direction is this one. And if you will talk about magnitude, then it have another formula which is equals to r magnitude is equals to under root x ka square plus y ka square plus z ka square. Hence it is equals to r vector ka magnitude is equals to x ka square, x is here 2, 4, y is here 3, 9, z is here 5 plus 25 is equals to it is equals to 38 under root 38. It is the magnitude of r vector, means if you want to calculate the length of this r vector, it is equals to under root 38 units. Okay, fine. Now we will talk about element in the Cartesian coordinate. Let this is a Cartesian plane represented by three coordinate axes x, y and z. It is represented by x, y and z. That's why it is called as Cartesian. Let's take a small volume here. A small volume which is a small cube of very small volume. This one here is the cube. If we are talking, there are three type of elements. First one is line element. We will talk about all these three elements. Second one is surface element. And third one is volume element. First one is here line element. Okay, line element. Actually, line element here is a very small length between the 2 points. Let these 2 points are this one and another one is this one. The length which will represent the diagonal of this cube, very small length, let its magnitude be dl. This dl is known as line element. Length of this small cube, it is equals to line element. Its magnitude is dl. If we write a vector expression here, dl vector, then this vector will denote a length of magnitude dl pointing along this direction. This complete line of magnitude dl pointing along this direction along the diagonal of this cube is actually the line element, which is dl vector. Now we want to write expression for this dl vector. As we wrote expression for the position vector earlier, in the similar manner we will write expression for this dl vector. Let assume the length traced along x-axis by this cube is equals to dx. Means this small length traced by this cube along x-axis have a magnitude of dx. D is representing here a very small change actually. The length traced by this cube along y-axis is this one. Let this one have a magnitude of small dy. And the length traced along z-axis, this one, let it have a very small magnitude is equals to dz. If we want to write a vector expression of these lengths, then we can simply write them as dxi cap small length along x-axis, dyj cap small length along y-axis, and dzk cap will represent a small length along z-axis. As we wrote the expression for position vector earlier, in the same manner we can write dl vector is equals to dxi cap plus dyj cap plus dzk cap. This is the expression for line element. If you want to get the magnitude of this line element, then we can write as dl vector का magnitude is equals to under root dx का square plus dy का square plus में dz का square. It is the magnitude of the line element. Now we will talk about surface element. Surface element will actually denote area vector. A vector which will represent area having magnitude is equals to area of that plane and direction along the perpendicular direction of that area. Let's take an example. As we took an example of that cube, it have 6 planes, out of which pairs are parallel. Therefore there are 3 random planes. One is this one, which is in the zy plane, another one is this one in the zx plane, and the third one is this one in the xy plane. Let's first talk about the surface element of the surface is small surface in the xy plane. Let this plane is xy and this small surface lies in the xy plane. Let the distance covered by this plane along x-axis is dx and along y-axis is dy. This one is dy. Then its area, small area dA, will be written as dx dy. It is a magnitude of area. As we were talking about surface element, I have already told you that surface element is a vector which have a magnitude is equals to area of that plane and direction along the perpendicular direction of that plane. Magnitude is here, surface of this surface is dx dy. Let's talk about direction. Direction of this area. Direction of this area will be in the perpendicular direction of this area. In the perpendicular direction of y and x, there will lie in z-axis. Let this one is the z-axis, representing a positive z-axis. And a unit vector along this positive z-axis, I have already told you, is actually k cap. Therefore, the line element can be written as dA vector is equals to dx dy k cap. This one is actually a line element in the xy plane along z axis. Direction is along z axis. Therefore, we will write it as dA vector z. Similarly, we can write another two surface element also. One is having a direction along x-axis and one is having a direction along y-axis. They, in a similar manner, can be written as dx vector is equals to dy dz I cap. Similarly, day vector is equals to dx dz j cap. These three are the surface element of this cube in the Cartesian plane. Hence, complete surface element can be written as sum of these three surface element, dAx vector plus dy vector plus dAz vector. This is the expression for the surface elements. Now we will come along over the volume element. Volume element is also a small volume of this cube. It is not a vector quantity, therefore it will not have any direction. Simply we have to write the volume of this cube, and that will be considered as the volume element of this cube in the Cartesian plane. dV, let's represent it by dV. dV is the small volume of this cube. As I already told you earlier that the small length along x-axis is dx of this cube, along y-axis is dy of this cube, and along z-axis is dz. Therefore, the complete volume of this cube can be written as the multiplication of length, breadth and height is equals to dx, dy and dz. This will be considered as a volume element of this particular cube. Okay, thank you for watching this video. Give a like and share to this. Thank you.